Most electronic products and devices are DC powered. Why not send DC power from the beginning? As you may know, electricity is generated at power plants from nuclear, hydro, and thermal sources. These power plants are often located in mountainous and coastal areas, making it more advantageous to send AC voltage to urban areas. Transmitting high AC voltage at low current minimizes transmission load. However, since the high AC voltage cannot be used in the home as is, these transform step down in stages by several substations before finally reaching 100 volts or 200 volts at the outlet. These transform voltages are also sent via AC, since AC is easier to transmit. A step-down transformer is a transformer that converts a high voltage at the primary windings to a low voltage at the secondary windings. In terms of coil windings, a step-down transformer's primary windings has more turns than the secondary winding. The transformer works on the mutual induction principle, also known as Faraday law of electromagnetic induction, which states that the magnitude of voltage is directly proportional to the rate of change of magnetic flux. The diode is a semiconductor device that essentially acts as one-way switch for current. It allows current to flow easily in one direction, but severely restricts current from flowing in the opposite direction. The process of conversion of AC current to DC current is known as rectification. The device that is used to convert AC to DC is rectifier. The rectifier corrects or strengthens the direction of the current. This device periodically reverses the direction of the alternating current to direct current, which usually flows in just one direction. Half-wave rectifier is a type of rectifier that allows one half cycle of an AC voltage waveform to pass while blocking the other half cycle. The full-wave rectifier is like two back-to-back half-wave rectifiers. The first half cycle, D1 is forward bias and D2 is reverse bias. This produces a positive load voltage across the load resistor. The next half cycle, the source voltage polarity reversed. This time D2 is forward bias and D1 is reverse bias. This also produces a positive load voltage across the load resistor as before. Bridge full wave rectifier. During the positive half cycle, D2 and D4 conducts while D1 and D3 reverse bias. Next half cycle voltage polarity reverse. Now D1 and D3 forward bias. This way, the circuit converts the AC input voltage to the pulsating DC output voltage. We do not need this kind of DC voltage. What we need is a steady and constant DC voltage, free of any voltage variation or ripple. To obtain such voltage, we need to filter the full wave signal. One way to do this is to connect a capacitor. Initially, the capacitor is uncharged during the first quarter cycle. The diode D1 is forward biased, so the capacitor starts charging. Charging continues until the input reaches its maximum value. The capacitor discharges through the load resistor until the next peak is arrived. When the next peak arrives, the diode D2 conducts briefly and recharges the capacitor. Pulsating direct current is a periodic current which changes in value but never changes in direction. Waveform in different stages. This is the pulsating DC voltage output. This is the pure DC voltage output. To obtain such pure DC voltage output, we need to use IC regulator. Using LM78 series regulator IC. See at the description box on how to make voltage regulator.